So we need to look at naming and writing formulas for compounds. And we're going to start simple here, and we're going to start with binary ionic compounds. We know ionic compounds are going to be made from metals with nonmetals. And we know they're going to be made with metals from nonmetals because in order for be ionic, we have to have something that's going to be a positive charge and something that's going to be a negative charge. We know metals, when they react, lose electrons, become cations. We know nonmetals, when they react, gain electrons and become anions. And we're going to start simply. We're going to start with type 1 here, metals, and nice, simple monatomic anions. So, charges. We can predict a lot of the charges from an element's position on the periodic table. We know our metals are always going to be cations, and for a lot of the main group, remember main groups are groups numbers 1 through 8. For these guys, we can frequently get the charge from the group number, and this is particularly the case with groups 1, 2, and 3. Things like sodium and magnesium and aluminum. Sodium is in group 1, and the group number is going to be its charge. Magnesium is in group 2, and the same here. Its group number is going to be the charge. Now we know these are positive because these guys are metals. We know nonmetals are going to form anions, they're going to become negatively charged. And one of the easiest ways to look at our nonmetals for the charge is we're going to take the group number that it's in and subtract 8. So if we have something like in group 6, for example, oxygen, if we want to remember the charge on oxygen, we simply take 6 minus 8, and that gives us a 2 minus. Remember, we write the 2 before we write the minus. So, binary ionic compounds. These are going to be made of 2 elements in some ratio, metal and a nonmetal. Our type 1. Type 1 is a metal with a constant charge, and this 1 means one charge only. And our type 1 metals, it's a short list, are going to be groups 1, 2, and 3. And then 3 other metals. And we need to memorize these charges, and they are silver, zinc, and cadmium. Zinc and cadmium are always +2, silver is always +1, and groups 1, 2, and 3, the group number is going to be the charge. Remembering group 1 is +1, 2 is +2, and 3 is going to be a charge of +3. And so we're going to take and put our nice simple type 1 metals with our non-metal anions. At the end of this slide, or end of this YouTube video, we're going to look at type 2. So, predictable charges. Group 1 is +1, group 2 is +2, group 3 is +3, and these right here give us the remainder of our type 1 anions. Now, if we have a type 1 metal, it's going to be the guys here that are on the left, and these are the constant charges. Now, hydrogen's a little weird. Hydrogen actually appears on both sides of the periodic table. You can also put hydrogen right here in group 7. Everything in group 7, when it's an anion, has a -1 charge. Hydrogen also has a weird property. It can lose an electron and make +1. We'll deal with that in a few moments. So our type 1 metals are these guys. Our type 1 or constant charge nonmetals are these guys right here, and including hydrogen. And we're going to deal with type 2 in a minute. So if we have our nice type 1 nonmetals, and these are going to be our monatomic anions, negatively charged because they've come from nonmetals. Now, to name these anions, and each anion has a distinct name, and you have to remember these. Our anions are named by taking the name of the element, for example, fluorine, removing the INE or the ending and adding "ide." So when we want to name these, are in group 5 here, and again, remember our charge is the group number -8. So if we're looking at something in group 5, it's going to have a -3 charge, and we're going to have nitride and phosphide. We're going to ignore the AS. If we have group 6, we have oxide, sulfide, and selenide right down here. Group 7, very important, are going to be the first one up here, for lack of a better place to put it. We're going to put hydrogen right there. And it's going to be hydride, and then we have fluoride, chloride, bromide, and iodide. Those are our monatomic anions, and you need to remember the name, the spelling, and the charges on those ones. So what are we going to do with this? Well, If we want to name ionic compounds made of type 1 metals, we're going to start with one we know, and that is NaCl. And we understand the patterns on these better than we think we do. When we see something like sodium chloride, first of all, it's always written as if it's neutral, even though we know this is in fact made of Na plus and Cl minus, but it's not written like that. It's written with no charges. We know the sodium is always written first, followed by the chloride, and we know how to name this. We know that this is called sodium chloride. And this sets up the pattern for all of the formulas and all of the naming with our ionic compounds. So the rule here is we're going to name the metal by the name of the element. At this point, hopefully you've got a lot of your elements memorized, so these are going to be straightforward. So when you see Na right here for NaCl, you go, okay, that's the first thing, the name of the element, and we're going to write sodium. Now we only have two things we do here. Either we write sodium, and then we follow it by the name of the anion. Chlorine we know is going to be with the metal. When chlorine here is with the metal, it makes an ionic compound. And when we have an ionic compound, we do not name this chlorine, we name this chloride. If we had a type 2 metal, we'd have to put the charge in the middle right here in Roman numerals. But this is a type 1, meaning one charge only, and we just call it sodium chloride. So if instead we had a compound of aluminum with, let's say, oxygen, we wanted to make an ionic compound out of that. We know this is ionic because that's a metal with a nonmetal. And we know we would name it aluminum oxide because we name it by naming the metal by the name of the element followed by the name of the anion. If we wanted to do a compound of Ca with Br, we name Ca by the name of the element, which is calcium. We name Br by the name of the anion, which is bromide. All right, but what about the formulas? So we know that sodium chloride is NaCl. So why do we write it as NaCl? We write it as NaCl because this is the simplest ratio. So this is the simplest ratio of cations to anions such that we have electrical neutrality, such that the charges sum to zero. So if we look at this, we have Na, the positive one, we have Cl with a minus one. Our charges on these guys add to zero, so our formula is simply NaCl. Charge here, or the charges simply add to zero. What if instead we had something like Ca with F? All right, well, we know what group calcium is in. Calcium is in group 2, so its charge is 2 plus. We know fluoride is in group 7, so its charge is F minus. And we have to take and figure out the ratio of these such that the charges add to zero. One simple way is to take the charge on one and turn it into the subscript for the other. It kind of cross multiplies for us. If we do that, it tells us that we're going to have one calcium and we're going to have two fluorides. Well, if we think about our charges there, one way to do this is just sort of block it out and see kind of what the net charge is. If we have two fluorides with a minus one each and one calcium with a plus two, our charges are going to add up now to zero, and our formula is going to have to be CaF2. The simple cross multiplying really doesn't work if you've got twos and fours, but we'll deal with that in a moment. So write our formula so that the charges add to zero. So let's do a couple. So let's say we go back to the case of aluminum with oxygen. We know how to name this, aluminum oxide. But what's the formula for this? Well, aluminum is in group 3, so the charge is plus 3. Oxygen is in group 6, so its charge is minus 2. If we take this number and turn it into the subscript, we're going to need 2 aluminums and 3 oxygens. And if we think about that, this is going to add up to plus 6, and this is going to add up to minus 6. And to write our formula, we have Al2O3. So when we write formulas for ionic compounds, we need to get the ratio for nice, clean, simplest ratio for electrical neutrality, such that these guys add to 0. So what's the next step? Well, the next step is if we consider our type 2 metals. So type 2 metals. Type 2 metal means it has more than one possible charge. So what would we mean by that? Well, iron was not in that list, so make sure you memorize which ones are type 1. Our type 1 metals are going to be groups 1, 2, and 3, silver, zinc, and cadmium. Everything else we're going to assume is type 2. It's not 100% perfect, but it's a pretty good start. Iron is one of the type 2 metals. The most common charges on iron are Fe2 plus and Fe3 plus. Now, these had old-fashioned names. In the old days, the lesser of the two charges ended in an us name, and we called this ferrous. And this one was the higher of the two charges we named with an ick, and this would have been called ferric. Well, unfortunately, most metals come in more than two possible charges, so that simple naming doesn't really work. So we have to be a bit more clever, and this is what we do. Remember, we name the cation by the name of the element. So if this is Fe, this is iron. And this one is also iron, but they're not the same iron. So we're going to take and indicate which one we have by putting the charge over here in Roman numerals. So this would be iron 2, and this one would be iron 3. We could do the same thing with copper or cobalt. Cobalt makes +2 and +3. And when we want to name these, we would call this cobalt 2 and cobalt 3. All right, so we got our nice. All right, so let's take a look here at our nice type 2 metals. Our type 2 metals are these transition metals. Our inner transition metals are also type 2. The exceptions on the transition metals that aren't are, again, these three right here, which we need to memorize. And these guys have variable charges. What are the charges? Well, you're going to have to look that up. But the better thing is that when we give you a formula, you can always figure out the charge. And when you name it, you have to be certain to tell us the charge. So let's consider this. So if we name our nice type 2 ionic compounds, we do it the same way as we do the type 1, except what we're going to do is give the charge of the transition metal using a Roman numeral in parentheses. So, for example, if we have CuCl, we know that we name a metal by the name of the element, so this is copper. We know we name our nonmetal by the name of the anion, so this is chloride. And then we ask ourselves, is this type 1 or type 2? Is it group 1, 2, 3, zinc, cadmium, or silver? If it's not, then we have to put the charge in Roman numerals. Well, how do we figure out the charge? We figure out the charge from the anion. We know that chlorine is in group 7, which makes this one -1. Therefore, in order to cancel the charge, copper has to be +1. So this is going to be copper 1 chloride. So let's do a few. What is the formula for nickel 3 oxide? So we're going to start out with nickel. 3 means +3. We know what oxide is. We know oxide is 2 minus. Because this number is odd and this is even, we can simply cross multiply. And this is going to be Ni2O3. Chromium 6 sulfide. Chromium 6 would be Cr6 plus. Sulfide would be S2 minus. Because these are divisible, we're not going to have 6 sulfurs and 2 chromiums. We need the simplest ratio on this. So instead of having Cr2S6, we're going to take and make that simpler, and we're going to have Crs3. We only need 3 sulfurs to cancel out that +6 charge. Copper 1 bromide. Well, copper 1 is Cu plus, bromide is Br minus, so this would be CuBr. So what is the name on these guys? Well, in order to do these, remember we name the metal by the name of the element. So I have manganese, and then I have oxide. I asked myself, is this type 2? Yes, it's in the middle. It's not in group 1, 2, 3. It's not silver, zinc, or cadmium. So I need the charge in parentheses in Roman numerals. So to get this, I have to go to the oxide. So I have manganese and I have oxide. Well, I know every oxide is -2, and there's 2 of them. Multiply by 2 right here, and so that's going to give us -4. There's only one manganese, so it itself must have a charge of +4 such that it charges sum to 0. So this is manganese 4 oxide. CRS, well, this is chromium, sulfide. We know that chromium is a type 2 metal. It's one of those transition metals in the middle, so I have to have its charge in parentheses. I'm going to get its charge from sulfide. Sulfide we know is 2 minus. There's only one chromium with it, so it must be +2 in order to cancel, and this would be chromium 2 sulfide. So next one, iron. Fe is iron. The N is nitride. So to do this, again, iron is a type 2 metal. We need the charge in the middle. So what do we have? We have Fe3N2. We know that each nitrogen is 3 minus. 3 times 2 here is -6, which means this must be +6. To go backwards, we're going to take 6 divided by 3, and we're going to get a charge of +2, which gives us naming of binary ionic compounds.